In this video, I'm going to explain the sun based on the Gleasons map. As you know, the Gleasons map is scientifically and practically correct and was used in England, Canada, France, Denmark, Sweden, Germany and Australia. I hope this video will be very interesting for Marilyn Spirit level channel. She is a great flat earth activist. You can find the link to her channel in the descriptions below and some other great flat earth channels as well. The sun is one of the most important things in life and also one of the most important things on this map. Welcome to the flat earth. Unfortunately, I cannot say let's start with a common knowledge, so I'll say let's start analyzing the Gleasons map. At 12 o'clock noon, that is at the meridian of Greenwich, the zero longitude line, the sun rotates around the pole and completes its cycle within 24 hours. That's one day. According to the Gleasons map, the sun rotates around the pole. The time is written on the map, Greek numbers from 12, 1, 2, 3 o'clock, 4 o'clock until 12 o'clock night, and then from the morning back to 12 o'clock noon when it reaches the meridian of Greenwich the next day. The sun does not only rotate around the pole, but during the rotation it narrows its path to the Tropic of Cancer, then continue to rotate and widening its path to the Tropic of Capricorn. It means during the seasons the sun moves between the Tropic of Cancer and the Tropic of Capricorn, and on the 21st of December it reaches its peak, and on the 21st of June its peak on the Tropic of Cancer. The sun travels around the circle in 24 hours time. The circle is divided in 360 degrees. It means the sun travels 360 degrees in 24 hours time. That means the sun travels 15 degrees every hour. So this is 6 o'clock, 7 o'clock is 15 degrees, and then 8 o'clock is 15 degrees, another 15 degrees, 10 o'clock, and so on. Let's measure the latitude coordinates for the Tropic of Capricorn and the Tropic of Cancer. But before that, let's have a look at another wonderful feature of the Gleasons map. December solstice, the sun is on the Tropic of Capricorn. The 21st of December it reaches its maximum, and you can also see where the sun illuminates the area. Again, the Gleasons map is scientifically and practically correct, and it's written on the map. On December the 21st, the sun moves around the Tropic of Capricorn and during the day lights up the southern portion of the Earth from the Arctic Circle to some portion of Antarctic ice. There is no sunlight, and sunlight is between quotation marks here, beyond 80 degrees south, but unknown region of ice. On the 23rd of December, the sun commences his northwards journey again, returning to his starting place, and thus completes his season. June solstice, the sun is on the Tropic of Cancer, and on 21st of June it reaches its maximum, and you can also see where the sun illuminates the area. The Gleasons map is scientifically and practically correct. It's written on the map. In the figures June and December, the white represents the sun's position in its respective month at noon. This shows sunlight inside the Arctic Circle for 24 hours. From June 21st, the sun moves round the tropic in a spiral circle, widening every day until it reaches its destiny on the southern or outer solstice on December 21st. It's written on the map, the sun moves. Scientifically and practically correct. Let's measure the Tropic of Capricorn. Can you see it? This is the 15th latitude line plus 5. It's 20 and then 21, 22, 23 and just a bit over the 23. So it's between 23 and 24. It's just over the 23 mark. And the Tropic of Cancer is also between 23 and 24. This is the 20, 21, 22, 23. As you can see, the 9 is 24, but sits between the 23 and the 24. I measured the Tropic of Capricorn between 23 and 24 degrees. Tropic of Cancer also between 23 and 24 degrees. So I had to search the internet and found it should be 23.5 degrees. Let's find out what the Gleasons map has to say. This is one of the most important things of the Gleasons map, the sun, and it's also one of the most important things a flat earther should know. The sun is one of the most important things in life, and it's one of the most important things on this map. This is a zoom-in situation from the seasons, the sun, the solstices, and the key of some secrets. So let's get started. The Gleasons map is showing us that the sun rises from the east, and during the seasons it moves from the north and the south, between the north and the south, between the Tropic of Cancer and the Tropic of Capricorn. This is the equator, the middle. The equator, Tropic of Cancer and the Tropic of Capricorn. And this is the equator. If the sun rises from the east and moves during the season between the south and the north pole, why is the north pole on the right? Because if the sun rotates around the pole and I can see the sun rises from the east, that means the north should be on my left hand side and the right south. But on the Gleasons map, the north is on the right hand side. This is one of the greatest secrets of the Gleasons map, and I'll explain it in the next video. The sun rises from the east and travels during the seasons between north and the south. That means between the Tropic of Capricorn and the Tropic of Cancer. The sun travels 30 degrees to the tropic to the north and 30 degrees to the south. It means the sun travels between 30 degrees north and south. This is 15 degrees, 30 degrees, 45 degrees. I am not looking at the longitude lines. This is a triangle, and this is an inverted triangle. It's the same triangle, the zero. This distance, the size, the distance is the same. Let me do it like this, maybe you can see it. This is 90 degrees, this is 90 degrees, and this is also 90 degrees. So it's the same triangle, same distance. This is 0 degrees, 15 degrees, 30, 45. It's an inverted triangle, so it's the same distance from the sun. On the equator is 0, 15 degrees, 30 and 45. So the sun travels 30 degrees until it reaches the summer or the winter solstice. The same on both sides. The center is the equator. So this is the equator. The sun travels from between north and the south. This is a quick drawing from the Gleasons map. The sun is at the equator. It's 0 degrees. That's why the equator is 0 degrees. And measured from the sun is 15 degrees, 30 degrees, 45 degrees. The equator is 0. This is not a latitude line. I'm just showing you the degrees measured from the sun. So if the sun is at the equator, it's 0 degrees, 15 degrees, 30 degrees. So if the sun travels during the seasons between the south and the north, it reaches the 30 degrees. If we're standing on the ground and look at the sun, we say, well, it's 90 degrees. And on the 15 degrees, it's 75 degrees. And on 30, it's 60. That's why this is not a latitude. Not only that, the distance between 15 degrees and 30 degrees and 45 degrees is not the same. It means if the sun is 15 degrees, if we measured the angle to the sun, we measured 75 degrees. And when the sun is 30 degrees, if we measure the angle, we measure 60 degrees. Because this is 90, we measure 60 degrees. But when the angle measured from the sun is 45 degrees and we are at latitude 45, we also measure 45 degrees. That is why this is very important, the latitude 45. Because the equator is the 0 and the latitude 45 is the latitude 45. But the 15 and the 13 is not the latitude, because this distance is not the same between 15 degrees, 30 degrees and 45 degrees. But the 0 is the same. The sun is straight above our head, is 90 degrees. From the sun it's 0 degrees. And when the sun is 45 degrees, if we are on latitude 45, we also measured 45 degrees. So this is very important. Let me draw an equator and explain more on an equator line. Okay, this is the latitude. This is the latitude. This is the sun's degree, 15, 30, but on 45, the angle of the sun is the same as the latitude. So if the latitude is 45 and the 0 the equator, they divided it in 15 degrees, equal size degrees, and the 60, etc. So the third 15, 30 is not the same, but the 45 degree is also the angle of the sun. So at 45 degree, if we are on the latitude 45 degree, if the sun is at the equator, we measure an angle of 45 degrees. This is very important. We know the importance of the 45 degrees. This is the latitude. The equator, 15, 30, 45. Equal size pieces. So this is the latitude. Equator is very important. The 45 degree is very important. And it's just divided between equal size pieces. The question is, where is the 23.5 degrees? The Gleasons map is telling us when we are at the equator, the sun is 30 degrees, we're looking at the sun, let's say this is also 30 degrees. If the sun drops on exactly the 45 degree line, we will look straight at the sun at an angle of 23.5 degrees. So this is the 23.5 degrees. It means if we are on a 45 degree latitude, we're looking direct straight to the sun as well. This is what the Gleasons map is telling us. Let's go back to our Gleasons map and I'll show you all the details. Marilyn, please pay attention. This is the equator. This is the 45 degrees latitude. Let's follow the 45 degrees latitude and see where it takes us. It brings us at the base of the triangle, the center, the equator, between the Tropic of Capricorn and the Tropic of Cancer, the 45 degrees latitude. If the sun is at the Tropic of Cancer or Capricorn, and you are at the 45 degrees latitude, you will see straight at the sun at an angle of 45 degrees. This is 45, this is also 45, from the 45 degrees when the sun is at the equator, and it tells you it is also 45 degrees. You're looking straight at the sun if you are on the 45 degrees latitude. This is also the 45 degrees latitude. It is the same as when the sun is at the equator. When the sun is at the equator on the 45 degrees latitude, is 15, 30, 45, also on the 45 degree latitude, you will look at the sun at an angle of 45 degrees. when you are at the equator and the sun is 30 degrees, that means on the Tropic of Cancer or Capricorn, you will look at the sun at an angle of 23.5 degrees. This is the 23.5 degrees. The Gleasons map is perfect. It's a masterpiece. It's a masterpiece. Scientifically and practically correct. I draw on my map just to show you, but you don't have to do that. You can use a piece of string, strong piece of string. I use dentifloss, and you can also measure the degree. If you stretch the string exactly to the center of the sun and the center of the small circle, it measures exactly 23.5 degrees. 23.5 degrees. Let me zoom in, see if you can look at it as well. Let's go back to our drawing board and I'll show you exactly how it is mathematically. I made a quick, beautiful drawing. This is the sun. This is the equator, the 45 degrees. The sun, when the sun is at the equator, the angle is 45 degrees, looking straight at the sun. When the sun moves to the 30 degrees, Tropic of Cancer or Capricorn, it will reach to 45 degrees and you're still looking straight at the sun, like the Gleasons map showed us. And if you measure this angle, it will measure 23.5 degrees. This is a beautiful example. An A4 piece of paper, folded and makes a perfect square. This is a perfect square. It's a square. Measure the 30 degree line. This is the 45 degree line, where the 30 degrees crosses the 45 degrees, exactly at that spot. If you measure the angle, it will measure 23.5 degrees from the equator. This is my beautiful sun. And the beauty of it, exactly on the same spot. Marilyn, now we know the importance of the equator, the importance of the 45 degrees latitude, the importance of the 45 degrees, the importance of the sun, the importance of the pyramid. Do you see what I see? Do you see it? Perfect triangle, equator, latitude 45, the base is flat and level. One thing is sure, everything is measured from a flat plane. The triangle and the sun, it's flat. The base is flat and level. Scientifically and practically correct. 1 degree is in reality 60 nautical miles. The 0 degree angle measured from the Sun is the 0 degree at the equator. The 45 degrees measured from the Sun is the same as the 45 degrees measured at the latitude 45 degrees. It means if we know the distance from the equator to the 45 degrees latitude, then we know the distance from the base to the top. It's written on the map 60 miles to the degree. It means 1 degree is in reality 60 nautical miles. 45 degrees times 60 nautical miles. Scientifically and practically correct. Thanks for watching, and I'll finish this video with some beautiful observations.